Good morning, class. Today we're going to go over some examples on how to predict the products of chemical reactions. If you're having any trouble, hopefully this will be a helpful video to help you figure out what the rules are. So let's look at some examples here and learn how do we predict the products of their reactions. It follows a few set of simple rules. Step one should be always identify the type of reaction. This will help you figure out what patterns and rules things usually follow. Step two, try to follow the patterns that are given. And one of the key things that you might have to do is step three, break all of your chemicals into ions. Following these three steps, you'll hopefully get a decent idea of what's happening, and that'll allow you to predict the products of these chemical reactions. Let's take a look at our first example. I see we have sodium phosphate and potassium hydroxide. There are two compounds, and if I remember my rules, two compounds will make a double replacement reaction. Now, what was the pattern that a double replacement reaction had? The pattern was that the metals end up swapping places. So my double replacement was step one, and seeing that the metals swap is step two. So doing step three will help me follow the pattern. I see for sodium phosphate, it's made of sodium, which is a 1 plus ion, and it's made of phosphate, which is a PO4 3 minus ion. And my other chemical, potassium hydroxide, is made of potassium, which is a plus ion, and hydroxide, which is a minus ion. Now they're going to swap partners, which means an A plus is going to bond with the OH minus. When these combine, I just have to bond Na plus and OH minus. There's one plus and one minus. Those things are going to bond, just making NaOH. What about the K and the PO4? I see the K is a 1 plus here and the PO4 is a 3 minus. That means I'm going to need 3 Ks to make 3 pluses in total to balance out those charges, right? So it will become K3 PO4. So by identifying it's a double replacement, remembering my pattern, and breaking these compounds into their ions, it helps me predict the products. Let's take a look at this next example because it gets a little more challenging. I see it's CaCO3 and that's it. Well, if I only have one set of reactants, that actually means my step one, my identify, means that this has to be a decomposition because there's nothing that this can do that isn't just splitting apart. Now, the pattern is that it's going to split apart. It's going to split into two pieces. So if I break this into my ions, this might give me a hint on what's going to happen. Calcium is an ion, and it is a 2 plus ion. And carbonate is an ion. It's a CO3 2 minus ion. Now, if I just split into those, that won't quite work because while calcium is something that you can find out in the wild that just exists, the carbonate ion doesn't exist that isn't bonded to something else. So we won't have just carbonate hanging around. That is where the challenge comes from. How do I figure out what this will turn into? Well, there is something that's super similar to carbonate, and this is actually a rule that all carbonates will follow. Carbonate is super duper similar to carbon dioxide. But what's the difference is there's an extra O. That carbonate is going to split into also an oxygen, leaving an O2 minus. Well, we're not actually allowed to have free ions floating around. That's not going to make the final product. So what I'm going to do is I'm going to take this carbon dioxide. That is a stable product. That's going to be one of my products there. And I have to find a way to combine or to relate my last two pieces. calcium and oxygen. Thing is, calcium combined with oxygen, or calcium oxide, is a very normal chemical compound. So it's actually very reasonable for us to predict that this is going to make calcium oxide. With this decomposition, we see that the rule for making this isn't hard and fast. We have to use a little bit of guessing and checking. That is actually normal for these types of problems, is that you might have to do a little bit of guessing. Let's take a look at another example here. Here we have silver nitrate and copper. Step one, I need to identify what type of reaction this is. I know this is a single replacement reaction because it's a compound reacting with an element, and that always tells me it's a single replacement. The pattern for the single replacement is that the element is going to replace the same type of compound. Now, copper is a metal, so that means it's going to replace the silver, because silver is the metal in that. So now that I know what type of reaction it is and the pattern, I can go ahead and predict some of these products if I separate the pieces into their ions. Silver is a 1+ ion, and this nitrate is a 1- ion. And then you're like, all right, the ion for copper. Now this is where it gets tricky. Copper is multivalent, and the common multivalent ions for copper is copper as a 1+ or copper as a 2+. And the tricky part here is, which one is it? And frankly, I don't have an answer. We weren't given that information. So this means when we're predicting products, we can choose either one. So you just have to go ahead and you have to choose which one you're going to use unless it has actually been told. So this chemical reaction, you could predict two entirely different products and you would be correct. You could predict the copper is bonding with the nitrate on a 1-to-1 basis, in other words, having copper 1 nitrate, or you'd be able to predict that the copper is bonding with the nitrate on a 1-to-2 basis, or it's copper 2 nitrate. Either one of those is a fully acceptable prediction. One thing that we are missing, however, is we didn't bring in our silver. So either CuNO3 plus Ag, silver, is an acceptable prediction, or Cu brackets NO3 and bracket 2 plus Ag is an acceptable prediction. With these ones, sometimes with our multivalent metals, you have to make a little guess, or there might be multiple options. Let's look at our very last example here. I see it's C3H6O and O2. When those are reacting, C3H6O is an organic compound, and oxygen means this is a combustion reaction. So my step one is identify that it is a combustion reaction. Now, what's the pattern for a combustion reaction? Combustion reactions actually have the easiest pattern. All combustions have products of carbon dioxide and water. Prediction done! Huzzah! The only thing that I would have challenge with here is having to balance this reaction. And that might take a little bit of time, but is entirely within your capabilities. Hopefully, these examples help outline some of the processes or some of the patterns that you might use to help predict the products. If you noticed, some of this actually involves just guessing, and that is okay to do. I hope all of you have a good time and continue practicing predicting products. Have a good day.